Now today we'll be discussing about kinematics. So before coming to kinematics, let's talk something about mechanics first. Right? Let's talk something about mechanics. Now what is mechanics? Now mechanics basically it is a branch of physics in which we study about objects that are either at rest or we study about objects that are either in motion. So in mechanics we study about two things, and these are rest and we study about motion. Right? Now mechanics actually has been divided into three. The first is known as statics. The second is known as kinematics. And the third is known as dynamics. Right? Now, to study about statics, or I can say to study about rest, we do that in statics. And to study about motion, we do that in both kinematics as well as in dynamics. So what do we conclude from here? We conclude that the first thing is that kinematics is a branch of mechanics in which we study about the motion of an object, right? Now, the additional thing that I want to add in my definition is that though we do consider about the motion of an object, but we do not take into account the force that has caused that motion. Now, let me give you an example. Let me say that I have a car and let me say it is moving in a particular direction with the speed of 2 meters per second, right? Now, in kinematics, we are interested about the speed, we are interested about its acceleration, and we are interested about the distance my object has traveled. But we are not interested about the force that has actually caused this motion, right? So the equations that would appear in kinematics would be free from force, right? The equations would not contain force, right? Now, having understood this, let's talk about the two terminologies that are frequently discussed in kinematics. And the first terminology is known as rest, and the second terminology is known as motion, right? Now, how do we define rest and how do we define motion? Now, rest, talking about rest, we say when an object is at rest, it doesn't actually change the surrounding. Or I can say for an object to be at rest, its surrounding should remain same with the passage of time. Now, let me explain. Now, suppose that I have an object, let me say this is a car, and let me say in its surrounding we have some trees, we might have some houses, and we might have some other trees. Now, if the surrounding is not changing with time, the surrounding is static with time, we say that this object or this car is at rest, right? Now, for an object to be in motion, it just needs to change the surrounding with passage of time. Now, if the object changes its surrounding with the passage of time, we say that the object is in motion, right? Now, I hope that you have clearly understood this. Now, let's move and talk something about important. Let's talk about types of motion. Types of motion. Now, the first type of motion that I am going to discuss with you is rectilinear motion. Let's talk about rectilinear motion. So what is rectilinear motion? Now, if my object is traveling in a straight line, we say that my object is having a rectilinear motion, right? So for an object to be in a rectilinear motion, it only has to travel in a straight line, right? Now, there is one more definition of rectilinear motion, and that is if only one of the three coordinates of the object are changing with time, we say that an object is in rectilinear motion. Now, what does this mean? Now, suppose that I have three coordinates, x-axis, and I have my second coordinate, y-axis, and I have my third coordinate, z-axis. And let me put my object here, right? And my object is moving in this direction. Now, if my object is moving in such a way that both y or z coordinates are changing and only the x coordinate is changing with time, we say that an object is in rectilinear motion. Or if only the y coordinate is changing and x or z coordinate are remaining same, then also we can say that an object is in rectilinear motion. Therefore, for an object to be in rectilinear motion, only one of the coordinate needs changing, needs to change, right? Now, there is a other term closely related to rectilinear motion, and that is translatory motion. Now, what is translatory motion? Now, basically, rectilinear motion and translatory motion have the same definition. The difference between rectilinear motion and translatory motion is that rectilinear motion is actually defined for a point object or an object with a unit mass, right? But translatory motion is defined for an object. Now, for an object, I mean for a car, for a truck, for a bus, anything, right? Now, this is the difference between translatory motion and rectilinear motion. Now, let's talk about the second type of motion, and that is, let's talk about circular motion. Let's talk about circular motion. So what is circular motion? Now, if an object is moving in a circle, we say that the motion it is traveling is a circular motion. Now, another definition that can be defined for circular motion is that if two of the three coordinates are changing with time, we say that an object is in circular motion. Now, what does this mean? Let's discuss this definition. Now, suppose I have my x-axis, I have my y-axis, and I have my z-axis, right? Now, if an object is moving in a circle, let's talk about this. Now, if an object is moving in a circle, now let me say I have this particle P which is moving. Now, at this point, what happens that it is having a fixed x-axis, x coordinate and y coordinate. Now, after some time, let me say my particle reaches here, and at this point it will have some other coordinate along x-axis and other coordinate along y-axis. Now, what is happening here is that with the passage of time, both its x coordinate and its y coordinate are changing. Now, if this happens, we say that an object is having a circular motion. So for a circular motion, two coordinates two coordinates change with time, right? Now there's another term that is closely related to circular motion, and that is rotational motion. What is rotational motion? Now, rotational motion and circular motion, basically they have the same definition, but again the difference between circular motion and the rotational motion is that circular motion is defined for a point object, while rotational motion is defined for a body, or I can say for a system, right? Now the third type of motion that I am going to discuss with you is oscillatory motion. Let's talk about oscillatory motion. Now, when an object moves to and fro about its mean position, we say that an object is having an oscillatory motion. Let's take an example. Let me say that I have a pendulum. Let me draw first. Let me say that I have a pendulum, right? Now when a pendulum is at rest, then this position can be called its mean position, right? Now if I give a small disturbance to this pendulum in this direction, what will happen that after some time my pendulum will come here, right? And what will happen after that, that it will again go back to its mean position, it will cross that mean position, and it will swing back to here, somewhat here. So after some time my pendulum will reach here. Now what is happening is that after giving the disturbance, my pendulum is having a to and fro motion about the mean position. Now this is known as to and this is known as fro. So the to and fro motion about the mean position, now this is known as oscillatory motion, right? Now I hope you have understood this. I will see you in the next video. Till then, take care and study smart.